Welcome to this session. In the last session, we were discussing integration testing, and we had discussed about the basic error target in integration testing. It said that the error target for integration testing are the interface errors, where one function calls another function and there is a problem in the calling, in the sense that the parameters are not proper. Even though as a unit the functions worked correctly, during calling there are problem, and integration testing targets to detect such problems. And then we had looked at the different types of integration testing. We said that the simplest integration testing is big bang testing. In big bang testing, we just integrate all the modules or units in just one step. But then we said that for a non-trivial program, nobody does a big bang testing. It would be too expensive to fix bugs in a big bang testing. So, the testing process will become extremely expensive. But then what are the other alternatives? Alternatives are the bottom up testing, top down testing, and a mixed or sandwich testing. Let us look at the bottom up testing. In bottom up testing, we take up the unit or the module at the bottommost layer of the design and then integrate it with one module which is at the same level, or if there are no modules available in the same level, we integrate with a module on the higher level, and so on until all the modules are integrated. So, at a time we integrate only one module, and we need to be aware what are the disadvantages of this bottom up testing. One is that we need to have drivers written as we do integration steps. Since we are testing the bottom level modules, we need to have some software written which will call these modules. So, for performing integration testing, the tester has to write these drivers. And the second thing is that the tester cannot really run the system level test cases, that is use cases. It can't really run meaningful test cases, only some very simple test cases. For example, whether data input from a user interface is correctly received, or whether the data written by to a user interface is correctly shown, and so on. That kind of very simple things need to be tested. And the way the bottom up testing works can be seen from this diagram. We start with the bottommost module, and if there are no other module at that layer, we take the next level, integrate, and then we integrate with another module in the same layer, 3 modules together, and then after they work successfully, they have been tested and any bugs fixed, then we take one more module, the same layer, again integrate and test it, fix any bugs that are present, and then take one more, and then the higher level, and so on until all the modules are integrated. So, this is the essence of bottom up testing. But then this is a incremental bottom up testing, and if some of the modules are really trivial, then we might even integrate 2 modules in one step. So, this is an example of bottom up testing. So, first we integrate M5 with M8 and we write a driver for M5, because M8 is being called by M5, but who would call M5, because M2 was calling M5, but we are not integrated M2, and therefore, we need to write a driver software which will call M5, and through this driver software we will test these to the M5 and M8. Now, we integrate, once M5 is successfully integrated with M8, we take up M6 and integrate with M5 and M8, and then we need drivers for both M5 and M6, because some software must call M5 and M6. We have not yet integrated M2, and therefore, we need 2 drivers here, and then we integrate one more, and now we need 3 drivers, and then we check whether these are working correctly. If not, we fix the bugs. Now, let us look at the top down integration testing. So, here as the name implies, start with the topmost module, and then we take one lower level module or a subordinate module and integrate them. And if the subordinate module is very simple, almost trivial module, then we might even take 2 modules in one step. And then once we have this top level module integration tested, we add the immediate subordinate module and so on. If we want to show diagrammatically that the order in which the modules are integrated, we start with the topmost and then integrate a subordinate module M1 with M2, and then integrate M1, M2 and M3 together, but just remember that here we will have to write stubs. Just like in the bottom up testing we needed drivers, in top down testing we need stubs, because observe here M2 is calling M5 and M6, but we have not integrated M5 and M6. We need to write small toy software which will act like M5 and M6, very simplistic software, not really providing all the functionality of M5 and M6, but at least some dummy functionality. Maybe through a table lookup, we have stored what are the results that M5 computes, the form of a table, and when that parameter is given, we just look up the table and return that value. That is the work of the stub here. So, when we integrate M1 with M2, we need 2 stubs, and then integrate M1 with M2 and M3. Then we integrate M1, M2, M3 with M4 and test, and here see we need 4 stubs. And then once we have tested it and made it to work correctly, then we integrate with M7 here, this module here, and then we would need actually 3 stubs, because this module is there, and therefore, we do not need a stub for this, we need a stub for only this one and this one. So, we need 3 stubs, and then next we take up this one, this module here, and therefore, we would need only 2 stubs and so on, until we have the full set of modules integrated. So, first we integrate M1 with M2. So, we need stub for with M1 and M2, we need stub for M3, M4, M5 and M6. So, in this situation, when you integrate M1 with M2, we need 4 stubs, because M1 also needs to call M3 and M4 and M2 needs to call M5 and M6. So, we need 4 stubs, and then the next step we integrate M1, M2, M3, and we need 3 stubs M4, M5 and M6. In the next step we integrate M1, M2, M3 and M4, and here we need 4 stubs for M5, M6, M7 and M8 and so on. And then we next take up with this module and then the next this one and so on. So, this is a top down integration testing. One advantage of the top down integration testing is that the test cases are actually meaningful use cases, because we are testing the top level functionality here, and also we reuse the same test cases as we integrate more and more module. So, earlier remember that we are testing the bottom level modules, we are needing different types of test cases to check whether these are working, but here the same test case we just keep on running with while adding new modules and we check whether those are working. So, that is advantageous for top down testing. So, the test cases are reused after integration, and also top down integration testing is advantageous if the bugs are in the top level module, because if the bugs are more at the bottom level module, then we would have by that time integrated many modules together and it would be difficult to localize the error. Whereas, if the bugs are at the low level modules, then a bottom up integration testing would be possibly more advantageous. The disadvantage is that since the low level modules are I/O and we do not integrate it in the beginning. So, observing meaningful system functions may not be possible to start with, and also stop design becomes a problem, because if for a non trivial program, when we are testing the top level modules, writing stubs for those way down would be difficult. The other alternative is a mixed integration testing, also called as a sandwiched integration testing. So, here it is more flexible in the sense that we have the liberty to use both top down and bottom up approaches as it suits us, and we would typically write we will typically integrate such that we need less number of stubs and drivers to be written, and therefore, mixed integration testing is quite popular. Let us look at how is this sandwich testing or mixed integration testing would work. So, we might integrate these 3 and then we might integrate these 3. So, some at the bottom level, some at the top level, and then we integrate them together. So, the number of stubs and drivers required to be written can be reduced substantially through a sandwich integration testing technique. So, another point that we need to observe is that if we are doing a top down approach, we can't really start testing integration testing until the topmost module is ready. So, in a purely top down approach, our testing has to wait until the top level modules are ready. Even though the bottom levels are available, we can do a pure top down testing. And similarly, in a bottom up approach, our integration testing cannot start until all the bottom level modules are ready. So, that is another advantage for mixed integration or sandwich integration testing, that even if some of the modules are available, we can start testing. Now, let us look at system testing. We had at the beginning said that system testing is a validation technique. The other types of testing are actually verification techniques. So, here in system testing we validate a fully integrated, a fully developed system against its requirements. So, the test cases are written by looking at the requirements document, and then they are tested on the fully working software to validate whether the software that has been developed is according to what was required for this software. There are actually three main types of system testing. One is alpha testing, the other is beta testing, and the third is acceptance testing. All three are system testing, but the names or the testing is depending on who does the testing. We call it as alpha testing, beta testing, or acceptance testing. If the system testing is done by the developing organization itself, the development team or the developing organization, we call it as the alpha testing. And if the testing is done by a friendly organization who are just asked to test and report if there are any problems, that is called as the beta testing. Whereas, acceptance testing is the system testing, where the customer does the system testing to decide whether to accept or reject the software. So, these are all these three are system testing, and depending on who carries out the testing, we call it as alpha testing, beta testing, or acceptance testing. In alpha testing, the testing is carried out within the developing organization, but then the test cases are largely designed based on the SRS document, because this is a system testing. In beta testing, it is tested by a select group of friendly customers. So, before the software is delivered to the customers, it is given to a set of friendly organizations just to test whether there are any problems. And then the final is the acceptance testing, where the customer is given the software and the customer carries out the system testing and decide whether to accept the software or reject it. And remember that in all the three types of system testing, alpha testing, beta testing, and acceptance testing, the test cases are designed based on the requirements document. Normally, do not have to look through the source code to carry out system testing. Now, the next question that comes is, if we have to do the system testing, what sort of testing we need to do? There are two major categories of tests. One is called as the functionality test and the other is called as the performance test. So, all these tests are both functionality and performance tests are designed based on the requirements document, and the functionality tests are done based on the functional requirements. So, we find out what are the high level functions there or the use cases and what are the scenarios, and then we do the functionality test, which are basically black box test cases, because we do not have access to the source code during system testing. And we had seen several black box test techniques: equivalence partitioning, boundary value, robustness testing, and so on. So, these are the different functionality tests that are done during system testing, and once the functionality tests the software successfully passes, then we say that the software is functionally correct. And then we need to carry out the performance tests. The performance tests are designed based on the non-functional requirements in a requirements document. So, as you might already know that in a requirements document there are two important sections, one dealing with various functional requirements and the other dealing with the non-functional requirements. The non-functional requirements are those which are not really functions, but then they document items such as what should be the reliability, what should happen when there is a power failure, what should be the throughput, how many data items can be input and results can be observed, what is the response time, and so on. So, those are the performance aspects. So, depending on the non-functional requirements that are there in the SRS document, we can have a large number of performance test cases. We can have stress tests, volume tests, configuration tests, compatibility tests, security tests, load test, recovery tests, maintenance tests, documentation tests, usability tests, and environmental tests. Now, let us see what are these different types of performance tests that are performed. What do we mean by stress test? How is it different from a load test? How is it different from a volume test? What do we do during recover test, and so on. The stress testing is also called as endurance testing. So, here we test the software with the situations that are not normally specified in the SRS document. If the SRS document specifies that we could the software could be used by 5 users satisfactorily, we check what happens when there are 6 users. Does the software crash or does it gracefully degrade? If it gracefully degrades with 6 users, then it is okay, it passes the stress test, but if it crashes, then it is not correct. Similarly, if the job size is specified something and if we give slightly larger job size, will the software perform very discontinuously? It will almost hang, or will it gracefully handle this? Utilization of memory. If we give a very memory intensive task, what happens? Does it suddenly hang? Does it crash, or does it gracefully degrade performance little bit? Remember that here we give we create conditions in this testing which is beyond what is specified in the SRS document. So, here most of the tests involve an element of time or size, how fast we give inputs, or what is the size of the input, what is the number of records transferred per unit time, maximum number of users active at any time, input data size, etc. And if our non-functional requirement specification does not tell anything about this, then of course, the stress testing would not be applicable. If it does not tell about how many users it should support, what is the rate at which data should be transferred, what should be the job size, data size and so on, then stress testing would not be applicable. So, this is an example of stress testing. So, let us say an operating system can handle at most 15 multi-program jobs, and now if 16 jobs are given, what would happen to the operating system? Would it just hang, or would it say that 16 jobs are not possible to handle, or would it just queue up one job and slowly degraded performance it will handle the 16th job? So, that is what we observe here. And for a real time system, we check what is the performance, time performance. So, if there are high priority interrupts, simultaneous high priority interrupts occurring, what happens? Is the deadline missed? Normally, a large number of high priority jobs may not arrive. The SRS document may say that only 3 arrive, but what happens if 4 arrive? Would the system gracefully handle that, or would it crash, or would it behave abnormally? So, that is what we check here. Another type of performance testing is the load testing. In load testing, we check whether the performance of the system under different specified loads is acceptable. So, that is one point in which the stress testing and load testing differ, is that in load testing we check the system performance under specified conditions, conditions that have been specified in the requirements document. But in stress testing, we test the software with conditions that are not specified in the requirements document, or those which beyond those which have been specified in the requirement document, we test the software. That is the stress testing. In load testing, we just check whether at different specified loads the software performs satisfactorily. For example, in a web based application, we might check if the requirements document says that the system should have a response time of less than 1 second when 100 simultaneous clicks or hits occur on the website. So, in load testing we will do that. Actually, we will have 100 simultaneous hits generated on the website, or maybe 90 hits generated, and we check how does the system perform. There are several tools available for doing load testing. One very popular tool, open source tool, is the JMeter, which can be easily installed and tested, available from the Apache website. So, we will stop at this point and continue in the next session. Thank you.